The Digital Twin Consortium has defined digital twins as virtual representations of real-life entities and processes. So to me, that follows that those virtual representations must be some form of systems. I'm not sure it makes sense to create virtual representations of discrete entities without seeing them as systems. So when we aspire to make those entities interoperate, to create the virtual representations of many entities interoperating with each other, we're talking about making systems interoperate. So systems thus have to be the common denominator in digital twins.
You know, I've seen other interoperability approaches centered around concepts like application, asset, product, resource, and none of these other concepts encompass all the cross-domain use cases that are applicable to digital twins. And as a result, they result in fragmented mechanisms for interoperability that don't effectively scale. The system concept, as you indicated, Anto, I believe is a common denominator that supports all these other entity types that require interoperability. When everything is viewed as a system, processes and capabilities can be normalized and modeled using a common meta model that is coupled to a common interoperability mechanism. I think the increasing adoption of digital twins by product manufacturers will drive this practicality. Manufacturers are increasingly taking a systems level approach to manage the complexity of their smart products. And I think these smart products are evolving into smart systems that can plug into a system of systems to form smart environments like a smart home, a smart building, a smart city. Once products are designed and produced as system-centric, then system-level interoperability can become practical when you standardize on a common mechanism.
Is it practical? It has to be. Otherwise, digital twins are just siloed representations of real-life entities, and there's not really much value in that. And this is exactly why we created this paper, to describe the characteristics of system interoperability so that we can figure out how to make a practical way of making those systems interoperate with each other at scale.
System interoperability, it can unify nascent ecosystems of high-value, multi-vendor smart systems, where those systems can be offered as services. It will enable businesses to compose their own system of systems that, from these inherently interoperable services, that can be tailored to their specific business requirements. I think system interoperability also enables scale. It will enable smart buildings to scale into smart cities, smart factories to scale into smart supply chains. I also think that the true potential of IoT and AI can be realized when they come together as one complete, interdependent, and interoperable system of systems that form a global ecosystem.
My view is that to create a really valuable digital twin or digital twins, we have to think in internet scale. The internet works wonderfully because of few very simple interoperable mechanisms, mainly internet protocol. They make every node in the world able to talk to another node at a packet level when they need to. We need to make systems behave in that way so that any system can talk to any other system in the same level as the internet. And we believe that digital twins, if we can make it interoperate in that way, then we would have something that is very, very valuable, as the internet is right now.